Hi, this is Kimber Spradlin, Senior Director of Product Marketing here at Moka5, and I'm going to spend the next few minutes talking about how to secure Moka5 on non-corporate laptops and desktops. So this would be for things like BYO, contractors, and independent agents. Let me start out with just a quick overview of Moka5's Live PC product. This is a secure container that allows you to create a second workspace on a Windows or a Mac device. That's a full corporate OS, application stack, and user data. And it operates completely locally, so it's copied down from a web portal to the user's machine, providing a lot of efficiency and very scalable infrastructure. Now let's focus specifically on how to secure this container, assuming that it is sitting on an untrusted host because it's a device that the organization does not own, control, or maintain. And we like to break it down into what we call the 7 layers of security. That means including encryption of the container itself up to AES 256-bit. It's a policy-controlled container that you can manage centrally and dynamically update. It has host-based check controls and AV, so before the container can ever be launched and decrypted, we verify that there's at least a minimal set of security capabilities on the host, that it's not infected by malware, for example. In addition to these capabilities, the container itself is tamper-resistant and copy protected so that it cannot be moved or edited by the end user. There are remote revoke, kill, or wipe capabilities so that if the device is lost, if it's replaced, if the employee leaves the organization or the contractor is no longer with you, then it can be easily wiped out, deleted, or just access removed while the data is retained, whatever the organization needs. This can be based either on a dynamic targeting basis or on a timed basis. So if that container is not connected to a network after 60 days, 30 days, then it's automatically wiped or the access is revoked. We also use LDAP or Active Directory integration for authentication so that we're incorporating as much of your security infrastructure that you already have in place and rely on. And all of this adds up to over 130 separate management and security policies that you control both on the container itself and the workspaces that are inside the container. Now let's dig into a couple of these layers in a little bit more detail. First, I want to start with the host-based checks. So as I mentioned before, there's really 3 ways that vulnerabilities on the host can cause problems for the workspaces inside the container. That would be keyloggers, screen scrapers, and host memory access. And what we do is incorporate AVG or ClamAV, depending on whether you're Windows or Mac, into the container. And it's compiled in, so it does not affect any kind of AV that the employee or the contractor might be running on the non-corporate owned laptop. And it also does not impact any kind of AV that you might be running within the workspace. So you can still use McAfee, Symantec, Sophos, whatever your preference in the container as well. But what happens is as that container is launched, the end user clicks on the application icon, it does a scan at initiation, verifies that no malware is present. You can also initiate custom host-based check scripts to confirm things like patch compliance, to confirm the presence maybe of a personal firewall, that the configuration meets your configuration baselines. This is going to be a fairly lightweight script because it is a personally owned device, so there's only so much control you can have. But you can state at a policy basis some minimum level of security that must be present in order to utilize the corporate container on that device. As those are initiated, once they're completed, if no issues are found, then the container is decrypted, The end user is presented with a logon screen. They use their Active Directory credentials, and they're in the workspace and can continue doing what they need to do for work. The next area I want to drill down and spend more time on are the policies. So we have, as I mentioned, over 130 policies for managing this environment. Some of those policies apply to the container itself, and then some of those policies apply to the workspaces in the container. And the workspace is what we call live PC. That is your virtual desktop with your operating system, your applications, your end user data. And in fact, you can have multiple workspaces inside a single container. And that's why it's important to separate out those policies. And policies on the container will be things like what encryption level you want to run at, as well as the host-based checking that I just mentioned. How frequently do you want those AV scans to run? When do you want them to run? What sort of actions might initiate one of those scans? And then the policies, then we have the policies as well that affect the workspace or the live PC. And so those are policies that impact things like single sign-on and what the user can do inside that specific workspace. To further secure this environment, some of the policies that you can set are things like the ability to write to a USB or a DVD, CD drive, use a printer attached to the host, really data loss prevention type capabilities. So those are some of the things you can do to secure the environment further in a non-corporate owned asset. You can also lock down the admin privileges. So the Moka5 operator, not only can you do this on a role basis, but you can control whether or not they can access the Moka5 management console from specific networks, so whitelist specific networks, to require them basically to be in-house at the time of accessing the Moka5 console. The other great thing that we allow is we enable, through integration into third-party tools, the ability to manage certain aspects of that container without having any kind of Moka5 credentials, so not needing that full access. For example, a help desk operator, you might want to give them privileges to revoke, unrevoke, or kill a container in case they get a call that a device has been lost out in the field. And this really operates on the security principles of least privilege. So really not giving them any kind of console privileges at all, just the ability to execute authorized functions from a tool that they already know, from their service desk application.